you want to build a rink that has an area of 1,800 meters squared. The length needs to be 30 meters longer than the width. What should the dimensions be? Alright, so to start, we know that the total area is 1,800 meters squared. So let's just go ahead and jot that down. And it's important for these types of questions to visualize it and sketch it to kind of help you see what's going on. We know that the length needs to be 30 meters longer than the width. The length is the longer side. So we can say length plus 30 for the length, or L plus 30, and the width is just W. So we can go ahead and write out the equation. Area equals length times width. Remember, we want to find the dimensions, but in order to do that, if we leave the length as L plus 30, the question is going to have two variables within it, which will be hard for us to solve that way. So let's make the length, or let's make this in terms of width. So for the length, instead of L plus 30, we can say W plus 30. So now we have one variable, which is W. It'll be easier for us to solve that way. So in the equation, we can replace L, that length, with the W plus 30. We can go ahead and plug in 1,800 for A. So 1,800 equals W plus 30 times width, or times W. So we can continue. We're going to distribute. We're going to carry down the 1,800. So we have 1,800 equals W times W, which is W squared, plus 30 times W, 30W. We want to set this equation equal to 0. So we're going to remove the 1,800 from the left by subtracting 1,800 from both sides of the equation. So that leaves us with W squared plus 30W minus 1,800 equals 0. All right, and this is as far as we can go. We can't really do anything more algebraically, but we can factor. This is a simple trinomial. So if we notice here, we want two numbers that multiply to negative 1,800 and add to 30. So I like to use the man rule. That is how I learned how to factor simple trinomials. It's how we typically teach it. So we want two numbers that multiply to negative 1,800 and add to 30. You could go ahead and pause the video and try to figure it out that way. Or what you could do is remove the zeros and determine which numbers add to 3 and multiply to negative 18. So in this case, we're going to get 60 and negative 30. Now this becomes W plus 60 and W minus 30 as our factors equals 0. Next, we want to set each bracket equal to 0 and solve for the variable, in this case, solve for W. So for the first factor there, we get W plus 60 equals 0. We get W equals negative 60. Now in this case here, just wanted to highlight something. We did get a negative solution. So this solution does not make sense for the problem. We cannot use it because we can't have negative measurements. Therefore, it's inadmissible. So we're not going to use that solution. For our next factor, we're going to set that equal to 0 and solve for W. So W minus 30 equals 0. W equals positive 30. And this solution checks out, or it makes sense. We have measurement, we have a positive answer. So we've found out what W is, or the width. We can make our therefore statement, because now we do know the dimensions of the rink. So we can say for the width, therefore the width should be, and we've solved for it straight above, so the width should be 30 meters. And for the length, we can say that the length should be, but if you remember, and I'm just going to finish writing out this last sentence here. And if you remember what we let the length be, so that was represented by W plus 30. We know what W is. If we sub in 30 for W plus 30, we get 30 plus 30, which is 60 meters. So there you have it. This is a pretty basic problem. Hope you enjoyed the video and can't wait to see you in the next one.